Considering that almost two-thirds of this rocket-powered aircraft's gross weight is fuel, the dangers of a takeoff from the ground are obvious. Close tolerances between pit dimensions and landing gear tread on the B-29 require expert handling by the ground crew, particularly the operator of the tug. Close tolerances, too, between the mothership and the XS-1 are closely watched, for even the slightest damage to the nose or tail section of such a high-speed aircraft would result in the direst consequences. Fabric straps connected by cable to the standard bomb hoist are used fore and aft to raise the airplane into position for connection with the bomb shackle. Once connected, braces will prevent swaying of the suspended aircraft. In order to fit the XS-1 as closely as possible into the bomb bay of the mothership, it had been necessary to cut away a section forward of the bomb bay as well as portions of the fuselage section of the rear bomb bay. With the loading operation completed, the mothership is towed to the nearby fueling station for refueling the suspended XS-1. Here, the same procedure of fueling with liquid oxygen, the mixture of alcohol and water, and the pressurizing of the nitrogen spheres is repeated. During refueling, the exposed sections of the oxygen line and the skin adjacent to the oxygen tank forward of the wing become coated with a layer of frost. This fueling operation normally takes about 1 hour, during which time every precaution and control is utilized to ensure a safe transfer of propellants and nitrogen gas. Upon completion of fueling, the B-29 is backed away. With ground clearance of the XS-1 barely a matter of inches, the mothership is now ready for takeoff. For locating the XS-1 in flight, a modified SCR-584 radar set is used. This installation permits accurate tracking, plotting, and airspeed altitude calibration of the airplane. An FP-80 aircraft assigned to this project is used for a chase ship and for photographing the XS-1 in flight. To enable the photopilot to keep the XS-1 in photographic range, a bomb sight was converted for use as a movie camera finder. A last-minute check between one of the engineers in charge and the B-29 pilot is made prior to boarding the airplane for takeoff. One of the greatest problems during the development of this project was the unpreventable loss of nitrogen pressure during the period of climb to launching altitude. Therefore, as rapid a climb as possible must be made to that altitude. Aside from the recognized dangers during fueling, getting this fully fueled experimental aircraft off the ground was, during the earlier takeoffs, considered a hazard. However, after 12 months of successful takeoffs, this procedure has been proven comparatively safe. During the same period, aborted flights were few and far between. These were caused by either some minor malfunction of equipment or a sudden and unfavorable change in weather. Here, with clouds beginning to obscure visible contact with the base, fuel in the XS-1 is jettisoned. Preparations are made by the crew of the B-29 for landing with the XS-1 still attached. During the earlier flight stages of this project, such a procedure was not desirable due to possible damage or loss of the XS-1 in an attached landing. But it has since been demonstrated that landings can be made with a reasonable margin of safety. Again refueled and checked out for another flight, the B-29 climbs as quickly as possible to the predetermined altitude. This may range from 15 to 30,000 feet. During this climb, contact is checked with the trailing photographic P-80 and the ground-based radar and radio installations. Inside the B-29, the crew and pilots check their equipment for flight at altitude and the checklist of coordinated procedure. For flights below 50,000 feet, standard Air Force personal equipment is used by the pilot of the XS-1. For the pilot's protection in entering the cockpit of the suspended aircraft, A small elevator lowers him to the level of the cockpit opening. Upon entering the cockpit, the pilot fastens his shoulder straps and safety belt and connects his oxygen mask and intercom. By that time, the cockpit door is lowered, positioned, and secured from the inside. This procedure invariably takes place at an altitude of 3,000 to 5,000, and the checking of the procedure list continues with the XS-1 pilot sealed inside his aircraft. Here the elevator can be seen in its lowered position opposite the cockpit door. Now, with contact and coordination established with ground radar and radio and the P-80 photographic airplane, the moment draws near for launching. 5 seconds. 4, 3, 2, drop. Number 1 cylinder is turned on, and the initial charge of alcohol appears as a puff of white vapor. Then, as oxygen is injected, the igniter fires the cylinder with flame and resultant thrust produced. With 1 cylinder firing, the photographic P-80 jockeys into position for a tail-on angle. With 4 cylinders producing maximum thrust, an almost vertical climb is possible. At higher subsonic speeds and approximately 8 miles away, the ground-based radar operators have to be on their toes while tracking. With the contractual flight test program with Bell completed in June 1947 and Air Force acceptance of the XS-1, 1 airplane was assigned to NACA for detailed stability, control, and loads investigation. The earliest of these flights were accomplished in October 47. With NACA cooperation, the Air Force initiated an accelerated transonic program on another XS-1, also in June 47. These flights with Air Force pilots were started 2 months later. These programs are being continued with the now favorable prospects of attaining speeds exceeding Mach number 1 and altitudes heretofore unexplored by any man-carrying aircraft.